Class, it's April the 16th. You're supposed to submit your second test today. Today is the deadline. Um, you can drop it in the mail. Make sure there's enough postage. The postmark will show that you were on time. If you need it, I can give you an extra day. You can. I did say at one point, Thursday, April 17th. Well, Thursday is April 16th today. You can submit it on the 17th. It would be best, though, to do it electronically if you submit it tomorrow. Okay, so we're going to conclude our series on Gauss-Jordan elimination this morning. In the previous video, we had a 3x3 example of a system that's inconsistent, that there are no solutions to. So we worked along here and we arrived at this point, and we noticed that these two equations are contradictory. Y plus 2z is 1, y plus 2z is negative 3. I mentioned during the video that you can stop at this point because you can't solve these equations simultaneously. If you have values for y and z that give you 1, and those values don't give negative 3. That shows this system's inconsistent, so this one is, so this one is. I did continue to show that you can finish triangulating the system. It's unnecessary, but you can do it. But I made a mistake right here at the end. So when we say negative 1 E2 plus E3 replaces E3, my eye focused on the wrong constant here. So what should this be? So we're changing the signs and adding. So negative y plus y is 0. Negative 2z plus 2z is 0. But here we have negative 1 minus 3. So this should have been negative 4. I wanted to make that correction. Okay. Now, I also just want to mention that if you study in the textbook or if you're getting tutoring, you've probably seen what's called matrix notation. For this type of problem, it's your choice whether you use matrix notation or just work with the equations. So the idea of matrix notation is that all you have to do when you work a problem with Gauss-Jordan elimination is remember what these constants are, what these coefficients are and these constants are. So we have 1, 3, negative 1, and 5. Negative 3, negative 8, 5, negative 14, and 1, 4, 1, and 2. So if you suppress the x, y, z equals, you save a fair amount of writing. But it's up to you whether you use matrix notation or work with the equations. Okay, now we're going to consider the underdetermined case. Let's start with a 2x2 example. All right, now I'm going back to an earlier video. I want to use the same example here. X plus 3y is 5, and minus 2x minus 6y is minus 10. Okay, so when we clear this entry, we double this one and add. And when we do that, the whole thing clears. 2x minus 2x is 0, 6y minus 6y is 0, 10 minus 10 is 0. So we get 0 equals 0. Now, the way to think about this is, remember we usually back substitute, but this equation allows us to assign any value we wish to y and let that value determine x. So there's a standard way of writing the solution. So we say, our back substitution goes like this. Y equals C equals any numerical value so then x plus 3c is 5, so x is minus 3c plus 5. So the solution set is x has this form and y has this form. So xy equals minus 3c plus 5c. Minus 3c plus 5c. So we can give c any value, that's the value of y, and that value then determines the value of x. Okay, let's look at a 3 by 3 example. Here we go. Okay, once again, I'm borrowing from the previous two lectures, so these two equations are identical to what we had the previous video and the one before that also. All right, so we're going to use this equation to clear this one, this term here, and then we're going to clear this one. So what do we do? So to clear this term, we need to triple and add, right? Triple this equation and add it to this one. So 3 E1 plus E2 replaces E2. All right, so 3x minus 3x is 0. 9y minus 8y is y. And minus 3z plus 5z is 2z. And 15 minus 14 is 1. That's exactly the same operation that we used twice the previous two videos. Let's save some time here. Let's do two steps at once. So let's clear this entry. So this time we multiply by negative 3 and add, right? We want to add to 3x and get 0, so we need to add negative 3x. So we multiply by negative 3 and add. So this is two operations combined here. All right, so minus 3x plus 3x is 0. Minus 9y plus 10y is y. Now, watch your signs. So we're multiplying this term by negative 3. So negative 3 times negative z is plus 3z. So 3z minus z is 2z. And minus 15 plus 16 is 1. Okay, now this may seem similar to what we did last time, but it's actually very, very different. These equations are identical. So far from being contradictory, if this equation is satisfied, this one is automatically. If you wish, you can clear this equation by multiplying by negative 1 and adding, or you can just cross it off, not because it's incorrect, but because it's redundant. This equation just repeats this one. So if you wish, you can say minus 1 E2 plus E3 replaces E3. And when you do that, all that's going to happen is you'll have 0 equals 0. Okay, so how does the back substitution work? If you don't mind, class, I'm going to create some space here by, remember I said you could delete this because it's the same as this. Okay, so this is 0 equals 0. Now we're going to back substitute. Now, the way to think about this is think of 0 as 0 times z equals 0. Think of it as 0 times z equals 0. So, no matter what value I give to z, this will be true, won't it? And then I can use that value to determine y, and then use those values to determine x. So we back substitute like this. So z equals c, the letter c, any letter at the beginning of the alphabet. You could use a, for example, any numerical value. Okay, so we take the value c and we put it here. So y plus 2c is 1. So y is, subtract 2c from both sides, minus 2c plus 1. Z is c, y is minus 2c plus 1. Now go to the top equation. Move these terms to the right, changing their signs. So x is 5 minus 3y plus z. And now substitute in the value for y and the value for z. So here's the value for y. And here's the value for z. And what we want to do now is simplify this expression using our distributive law. So continuing, x is 5. Now use your distributive law. Minus, or rather plus, minus times minus, 6c minus 3 plus c. Let me make sure I'm on the right track here. Okay, so we have 6c and c. We can combine those terms. 6c plus c is 7c, and 5 minus 3 is 2. Okay, so we have our general solution now. We can assign z any value we like, and the value we choose will determine the value of x and y and then x. Now you can check this answer. You can go back to the original equations and replace x by this expression, y by this expression, and z by this, the letter c. And what will happen is use your distributive law and combine terms, and there'll be some c terms, but they'll cancel. So you can verify that any x, y, z of this form, and so will satisfy not only this equation but this one and this one. I wanted to show you that, but the video is already sufficiently long, so I'll let you deal with that issue.